Good day, everybody. Today we're going to discuss about computer systems. We're going to discuss three: the central processing unit, the processor, and how data is processed in the CPU. Okay, first up is the CPU. Let's say the CPU is the whole brain of the computer. It takes every bit of information and processes it to become an output. The CPU performs basic arithmetic, logical, control, and input-output operations specified instructions by the computer. Basically, everything that happens through the computer goes by the CPU. Everything from the user to the software to the applications used in the computer goes by the CPU. The processor is included in most part of computer devices and anything that uses microchips. The processor is kind of like the helper of the CPU. These processors contain physical cores. These cores are filled with all kinds of processes. One physical core, but it's filled with millions of processes that go on at the same time. And lastly, for the how data is processed. Data is processed by 4 steps. First step is the program, which is stored inside the hard drive, is transferred to the RAM, a program of series of instructions through the CPU. Second, the CPU, using a circuit called memory controller, loads the program data from the RAM. Third step, the data now inside the CPU is going to be processed. And lastly, the processed data is used by the appropriate software needed by the computer or anything else. Thank you for listening.
Today, we're gonna talk about the von Neumann architecture and the 4 main subsystems. The von Neumann architecture was made by John von Neumann in 1945. It consists of a processing unit containing an ALU and a PR. It also has a control unit containing an IR and a PC. Also a memory to store both data and instructions, external mass storage, and an input and output mechanism. A computer consists of 4 main subsystems, namely the memory, the ALU, the CU, and the I/O system. The memory subsystem. The memory, also called the RAM or the random access memory, it consists of many memory cells of a fixed size. Each cell has an address associated with zeros and 1. Next one. The RAM. It needs to be distinguished between the address and the content of the cell. The memory width, it measures how many bits is in each memory cell, typically 1 byte or 8 bits. And the address width contains the address space. The operations on the memory. It holds 2 operations, the fetch and the store. Fetch a copy of the content of memory cell with the specified address, while store, it stores the specified value into the memory cell specified by the address. The memory system is interfaced via the MAR, MDR, and the fetch and store signal. This is the structure of the memory subsystem. It has 2 operations, the fetch and the store. When it fetches an address, it loads the address into the MAR and decodes it, while when it stores the address, it loads the address into the MAR and loads the value into the MDR, then decodes it back to the MAR. The ALU, or the arithmetic logical unit. The ALU performs the mathematical operations like addition, subtraction, division, and multiplication, and also do the logical operations like less than, more than, equals, and or. It consists of circuits to do the ALU operations, and the register, and the bus that connects the two. The CU, or the control unit. This is the structure of the CU, the PC, or the program counter. It stores the address of the next instructions to be fetched. The IR, or the instruction register, stores the instruction fetched from the memory, and the instruction decoder, which decodes the instruction and activities of necessary circuitry. The task of the control unit is to execute programs very repeatedly, fetch the next instruction to be executed from the memory, decodes it, that is, determine what is to be done, execute it by issuing the appropriate signals to the ALU, memory, and the I/O subsystems. It continues until the halt instructions or the so-called deadlock. The input and output controller. The I/O handles devices that allow the computer system to communicate and interact to the outside world. For example, the monitor, the keyboard, and the printer. It also stores information like the hard drives, the floppy disks, the CDs, and the tapes. This is the structure of the I/O subsystem. The I/O controller. It has a small memory buffer and a control logic to control the I/O devices. It sends an interrupt signal to CPU when done reading and writing. The data is transferred between the RAM and the memory buffer. The mass storage devices access methods. One is the direct access storage devices, or the so-called DAS-D. The DAS-D has the ability to obtain data from a device by going directly to where it is physically located on the device rather than by having to go through everything. The sequential access storage devices, or the so-called SAS-Ds, has a class of data storage devices that stores data in a sequence. Thank you.
Hi, now we'll talk about memory, ROM, and RAM. So, memory measured by the number of bytes available in the storage. RAM. It is a form of data storage that can be accessed random at any time, allowing the user to have quick access and manipulation of data. All instructions are loaded in and out of RAM. For operating system, when you start the computer, certain operating system files are loaded into RAM from the hard disk. The operating system displays the user interface on the screen. For web browser instructions, when you start a web browser, the program's instructions are loaded into RAM from the hard disk. The web browser windows is displayed on the screen. Word processing program instructions. When you start a word processing program, the program instructions are loaded into RAM from the hard disk. The word processing program window is displayed on the screen. ROM. It is a built-in computer memory which contains the programming that allows the computer to be booted up each time it is turned on. This is the types of ROM. ROM, read-only memory. ROM, programmable read-only memory. EEPROM, erasable programmable read-only memory. EEPROM, electrically erasable programmable read-only memory. And the last one, flash EEPROM memory. ROM. Creating ROM from scratch is very time-consuming and expensive in small quantities. So, ROM was invented. It allows the user to program this type of ROM using the proper programming devices. EEPROM. Even though ROM are inexpensive per chip, the cost can add up over time. So, EEPROM was invented. EEPROM chips can be rewritten many times. Erasing an EEPROM requires a special tool that emits a certain frequency of ultraviolet light. EEPROM and flash memory. This type of ROM allows the user to manipulate data such as turning device and deleting data using the computer.
Hello guys, my name is James Benedict Montes and I'm here to discuss to you what is storage devices. So what is storage? It holds data, instructions, and information for future use. Primary storage device it is a medium that holds memory for short periods of time while the computer is running. And it is volatile in nature. When you say volatile, when the computer is turned off, all data that is loaded inside the primary storage will be erased. Now, the secondary storage device, it is a non-volatile device, meaning even if the computer is turned off, all data and instructions that are stored in the secondary storage device will not be erased. It is a device that holds data until it is deleted or overwritten. Storage medium, it is the physical material used for storage, but it is also called the secondary storage device. An example of primary storage device is the RAM, or the random access memory. Now, these are the examples for secondary storage devices: floppy disk, the optical disk, and the magnetic disk. Magnetic tape, I mean. Magnetic tape, it is used in recording sound, pictures, or computer data. It has been in use for more than 50 years. Floppy disk, it is a flexible, removable magnetic disk, typically encased in a hard plastic, used for storing data. They were widely used from the 1970s to the early 2000s. Now, this is the optical disk. An optical disk is an electronic data storage medium that can be written to and read using a lower powered laser beam. Now, these are the types of optical disk. CDR means recordable compact disk. It was developed by Sony and Philips. It allows the user to store data, but only once. Now, the CDRW, or the writable compact disk, it is also the same as the recordable compact disk, but the thing is, it allows the user to store data for multiple times. And this one is the last type of optical disk, the DVD-R, or the recordable DVD. A type of recordable DVD has a storage capacity of usually 4.1 gig. Thank you.
Hi guys, today I will be discussing about contemporary multi-level machines. So firstly, a program is a sequence of instructions that is executed and tells how to execute a specific task. Language. Computer's primitive instruction form a language in which it is possible for a human to communicate with a computer. Translation. It's a way of executing a program by replacing each instruction with another instruction which is equivalent to the corresponding instruction and then executes it directly. Another way is to create a program that uses programs as its input and analyzes each instruction, then executes it directly, which is called interpretation. Virtual machine. Virtual machines operate based on the computer architecture and functions of a real or hypothetical computer. Their implementation may involve specialized hardware, software, or combination of both. Multi-level machines. So level 1, actual computer. With machine language L1, programs in L1 can be directly executed by the electrical circuits. Level 2, virtual machine 2 with machine language L2. Programs in L2 are either interpreted by an interpreter running on M1 or are translated to L1. Level 3, machine language M3 with machine language L3. Programs in L3 are either interpreted by interpreters running on M2 or M1 and are translated to L2 or L1. Level N, virtual machine MN with machine language LN. Programs in LN are either interpreted by interpreter running on a lower machine or translated to the machine language of the lower machine. Contemporary multi-level machines. Digital logical level. Each gate has one or more digital inputs which represent signals representing zeros and ones, and computes as output some simple functions such as AND or OR. Microprogramming level. Level 1. Microprograms are directly executed by the hardware, a true machine language level. There is no concept of a program as a sequence of instructions to be executed. There's definitely a program called a microprogram whose job is to interpret the instructions of level 2. Level 2. Conventional machine level. Interpretation or microprogram. On these machines, the conventional machine level instructions are carried out directly by the electronic circuit level 0 without any level 1 intervening interpreter. Level 3. Operating System or OS, or also called as partial interpretation, is a hybrid level. The new facilities added at level 3 were carried out by an interpreter running at level 2, which historically has been called an OS. Some of the level 3 instructions are interpreted either the OS or the microprogram. That makes it hybrid. Level 4. Assembly language level, called as translation or assembler, are the intended for the application programmers with a problem to solve. Level 5. Problem-oriented language level. Translation/compiler consists of languages designed to be used by application programmers. These are called high-level languages. Level 6. User language level consists of applications of programs designed to create machines specifically tailored to certain applications. And here's how to develop a multi-level machine. When developing multi-level machine, the programmer must decide what to put in each level. This is generalization of the problem mentioned earlier of deciding what to put the hardware and what to put in the software. Thank you.